Borger High School Chemistry. This is Unit 4, Atomic Structure and History, and this is Part 4 of the podcasts. All right, so we're looking at atomic structure, and you should be looking on page 2 of your notes, about the middle of the page, for number 7. Number 7 is the atomic number. We talked briefly about it in the last section. The atomic number refers to the number of protons in an atom. If it's a neutral atom, which when we say the word atom, we mean neutral atom, then if you know the atomic number, then that tells you the number of protons. And if you know the number of protons, like it's got 7 protons, then it must also have 7 electrons to be neutral. So 7 positives, 7 negatives, they equal out when you add them together, they equal out to be 0. So the atomic number for a neutral atom tells you the number of protons, and you can also assume it tells you the number of electrons in it. The mass number, or the atomic mass number, sometimes it's referred to the atomic weight, is the number of protons plus neutrons. Atoms of the same element can have different numbers of neutrons. They don't, like if you have a bunch of gold atoms, they don't all have to have exactly the same number of neutrons. They'll be similar, but there'll be some differences there. So the proton number is always the same. So gold atoms always have a certain number of protons. Oxygen atoms always have 8 protons. Hydrogen atoms always have 1 proton. If it's got more than 1 proton, it's not hydrogen. But the neutron number can be different. So you can have a hydrogen atom with 0 neutrons. You can have one with 1 neutron. You can have one with 2 neutrons. And they're all hydrogen because they all have 1 proton. So the protons really tell you what element you have. The average mass is what's actually written on the periodic table. If you add the protons plus the neutrons, you should get a nice whole number, because you can have a piece of a neutron, right? But when you look at the periodic table, if you look at the mass number for oxygen, it's 15.999. Well, you can't have 0.999 of a neutron. So you realize there's something weird going on here. And in this case, it's the fact that they've taken all the oxygen atoms and they've said, well, what's the average mass? Well, some oxygen atoms have 8 protons, and some oxygen atoms have 8 neutrons, and some might have just 7 neutrons. And so your number's not exactly 16, it's an average of that. Okay, so here again we have the basic structure of the atom, the electrons orbiting around the nucleus. Now, where the electrons orbit, sometimes some books call them orbits, some of them call them orbitals or shells or sublevels, things like that. So you have to be careful about it. In the next unit we do, we'll talk a lot about the electrons. An atom of hydrogen has 1 proton and 1 electron. And the majority of them have no neutrons whatsoever. If you have an atom of lithium, most of them have 3 electrons, 4 neutrons, and 3 protons. Okay, let me say that again. All of them have 3 protons. It's not lithium if it doesn't have 3 protons. In a neutral atom, it's also got 3 electrons. And then it also has, the majority of them have 4 neutrons. Now, you'll notice the arrow from the electrons, it's not pointing at the right thing, and I'm just not going to go back and fix it right now. I'll fix it for next year. Okay, number 9 on your notes. Atoms always have an electron number equal to the proton number. So electrons equal protons when you're in a neutral atom. Now, beryllium has 4 electrons and 4 protons. Again, my electron arrow is not pointing at the right thing, so I'll fix it later. Number 10, ions. Ions have an unequal number of electrons and protons. So you end up with something that either has a positive charge or a negative charge. Something's different. And we haven't altered the number of protons. If we mess with stuff in the nucleus, we're doing nuclear chemistry and nuclear physics. We don't do that. We're talking radioactive stuff. We don't do that in normal chemistry. What we do is we mess with the electrons. They're on the outside. They're easier to get to. You know, you can walk across the floor on a carpet. You know, when you rub your feet across the floor on a carpet, you can actually strip electrons off of the carpet atoms, and you can transfer them. You know, when you reach out and touch a door or some metal piece, you can shock something. You've actually scraped electrons off of something and transferring them around. So it's easy to get access to the electrons. So ions have an unequal number of electrons and protons. An ion is an atom or a group of atoms. You can have a poly means many, polyatomic ion too. And it has a net negative charge or a net positive charge. A cation is an ion with a positive charge, And in this case, if you look at it, you've got a neutral atom. It's got an equal number of protons and electrons. But if we swipe one of those negatives on there, out of there, if we take away one of the negatives, you end up with 11 protons and only 10 electrons. So you've got one more positive than you have negative. Notice that the atom shrinks in just a little bit. It's a little bit smaller than the original. You have less stuff. You can kind of think of it as having less stuff on the outside. You've got a stronger pull of those positive charges, and the negative charges are pulled in towards there. An anion is just the opposite. It's going to be an ion with a negative charge. So if you have the chlorine, it's got 17 protons, 17 electrons. If it steals an electron from somebody, it'll have 18 electrons. It's got one more negative charge than it has positive charges, and then you've got an ion with a negative charge. Notice that the chloride ion there is larger. It's got more stuff orbiting around it, so it's taking up a little bit more space there. You can kind of think of it like that. We'll talk about more about it later. All right, here's a boron ion. It has 7 electrons. And look on the inside, the protons, there are only 5 protons, little white ones. There are only 5 protons. So 7 negatives and 5 positives ends up to be a -2, so it has a -2 charge. Now, the other thing we're talking about, so we talked about atoms. They're neutral. Ions have a charge of some type. And then we have something called isotopes. And isotopes are atoms of the same type that have differing numbers of neutrons. So that means their masses are going to be a little bit different. So you have an oxygen atom with 8 neutrons, and you have another oxygen atom with 7 neutrons. They are called isotopes of each other. Now, you'll notice there's another video on isotopes. We'll see that one tomorrow in class. Right, here are the isotopes of hydrogen. So if you look down there in the picture, you've got the first one on the left, and it's got 1 proton, and they really just ignored the electrons because we're not really focused on this. We're just looking at neutrons and protons. So if you look at the little red dot in the middle, that's a proton. And you notice every one of them only has 1 proton. But the first one has 0 neutrons, and that's the most common way hydrogen is. The vast majority of hydrogen atoms, they don't have neutrons. Look at the second one. The second one has 1 proton and 1 neutron. And then the third one over on the far right, it's got 1 proton and 2 neutrons. And look at the little symbols beneath them. The first one, there's a number on the bottom, and the number on the bottom left is always going to be the atomic number, how many protons does it have. So you notice the symbol is H, and the bottom number on all of these to the left of the H is always 1. That's how many protons it has. The top number is the mass number. Remember, mass number is protons plus neutrons. So in the left-hand thing there, you've got 1 proton plus 0 neutrons, so the mass number is 1. In the second one, you have 1 proton plus 1 neutron, so you have a mass number of 2. So the little 2 on top on the left is going to be a 2. And then on the third one, you have 1 proton and 2 neutrons. 1 plus 2 is 3, so you have a mass number of 3, and that's what's written in the upper left corner. All right, atoms of the same element with different masses are called isotopes. Let's see. I think this is just going to go over it briefly. Oh, this is how you write the nuclear symbol, and I think this is one of the things that you'll have to do or recognize on the tax test. So when we have C is carbon, and the number on the lower left is the atomic number. How many protons does it have? It's got 6. And then the number on top on the left is the mass number. If it's got 6 protons and the mass number is 12, subtract those, and that'll give you the number of neutrons. So this is carbon 12. So here's the mass number, the atomic number, and the little hyphen notation. If they write it out without all the symbol and everything, then they would call it carbon 12. So again, here we have some more pictures, lovely pictures of isotopes. We have carbon 12 on the top, and then over on the right we have carbon 14. And carbon 14 has, instead of 6 neutrons like the one on top, you have 8 neutrons. But notice that the protons are still 6 and the electrons are still 6. We don't care about the electrons usually when we're talking about isotopes, though. Ions are the ones that care about the electrons. Isotopes care about the neutrons. All right, so here we have some examples. Chlorine it's chlorine 37. So if we look at it and we look on the periodic table and find chlorine, it's number 17. The atomic number then is 17. The mass number, it tells us right there, chlorine -37. That -37 tells us the mass number, so the mass number is 37. How many protons does it have? That's the atomic number, 17. How many electrons? Well, it's a neutral atom. It doesn't say it has a charge, so it should be the same as the proton, so it's 17. How many neutrons? 37 minus 17 is 20. So that's how we can use those. And we'll do some practice on those so it won't just freak you out as it stands now. So when we write this, we write it, and this is just the notation for writing the nuclear structure inside there. So we have the symbol for chlorine is Cl, capital C, lowercase l. The atomic number is on the lower part on the left, 17, and the mass number is on the upper left, and that's 37.